In this lesson, we're going to look at how to graph polynomial functions. So consider the function of f of x, it's cubic. So you should know that it has 3 zeros, whether it's complex or imaginary, and I can see that we have 1, 2, 3. Notice it has some peaks and valleys. So if you think about what points would help you sketch this polynomial by hand, hopefully you're thinking, well, the zeros would, as well as these peaks and valley, which we are going to call extrema. So to graph polynomials of higher degree, find the zeros and any extrema. So let's talk, what on earth is extrema? It's simply like your peaks and your valleys in your curve. So we have absolute extrema and local extrema. So think of absolute as like the absolute highest the function will ever go, or the absolute lowest. Local is in a local area, like you could think, where in my town the highest point is such and such, but you know what, in the entire state there's a much higher place, which would be the absolute extrema. Okay, so we have an absolute maximum, and a graph that has an absolute maximum might look something like this. So maybe the curve is like this, and this point right here is the absolute highest it will ever get. That's my absolute max. An absolute minimum value would be when your curve is opening upward. So maybe it looks something like this. Well, the absolute minimum value would be right here. Now, as far as local extrema, so we could have a local max. A local max would be, so let's say you have something that goes really high, but then you know what, there's another peak, but it's not the absolute highest. This one right here would be your local max, whereas this one would be the absolute max. Okay, and then we can have a local minimum as well. So local minimum would be if your curve is facing the other direction, or maybe it goes like this. So this goes forever up and forever down, so it wouldn't have an absolute minimum, but this little valley right here in that local area is a local min. Okay, so we're going to practice now finding our zeros and extrema. So we are going to list our zeros. So first of all, I know that I have a 0 at x equals 2, and it's there twice because it has multiplicity 2, and a 0 at -1. So I'm going to plot those points on my function. I know it'll bounce off the graph here at 2 because it's there twice. I want to check and see if we have any absolute max or absolute min or any extrema. So to do that, we're going to rely on the graphing calculator. So you're going to type in your function. I'm going to actually make my window match what we have here on this coordinate plane. If it's not a good coordinate plane, we'll switch it. So -6 to 6 for both the x and the y. And I'm going to hit graph. Take a look at my picture. So there I can see that indeed it crosses at -1 and it bounces off at 2. And I'm going to get, I'm going to look and see right here, this looks like a relative or local maximum. Okay, it's not the very highest the graph goes because it goes forever up, but let's see what this value is, and it also looks like the y-intercept. So I'm going to hit trace, and it is the y-intercept, so trace 0, I can see that it's crossing at 4 for my y-intercept. So I'm just going to sketch my function now with the help of my graphing calculator. You can see it goes up like this, and it comes back down, bounces off, and it goes back up. You did do a great job right there. I totally missed my 1, 0. Just clean that up a little bit. Okay, so I want to talk about my point right here, which is a local maximum, because it's like a peak on a hill on a roller coaster. My local max would be the point 0, 4. Notice it's also the y-intercept. I believe I have a local minimum. Okay, so again, if you're on a roller coaster, you're going up, there's the top hill, comes down. This valley right here is going to be a local minimum. It's not the absolute lowest this graph goes because over here on the left it goes down lower, And that point, we saw that was actually a 0. It's the point 2, 0. The other thing we need to always do is state our domain and our range. So our domain is, well, how far left does this graph go? Well, it's going to go forever to the left. It's going to go forever to the right. So my domain here is all real numbers. My range, how low does it go? Well, it's pointing downward and it's pointing upward, so you guessed it, the range is also all real numbers. For number 2, I've already sketched it in my graphing calculator, and I know that I need my zeros. So I'm going to use the graphing calculator to find it since it's not in factored form. So I'm going to do second trace, option 2 for zeros. It's going to ask me 3 questions, remember, left bound, right bound, guess. So I need to be to the left of where it crosses the y-axis. I can see it's positive, so I hit enter. To the right of where it crosses, enter, and guess. So my 0, I'm just going to go to 1 decimal place here, the nearest tenth. So that's negative 0.9, 0. So not quite at negative 1, and I'm going to put my point there. I'm going to just see what my y-intercept is because that'll make it easy, negative 3. And I need any local max or min. So I can see that it's curving right here and then it goes back up a little bit. So it sure looks to me like this 0, negative 3 is a local minimum. It's a valley. Okay, so I have a local minimum at 0, negative 3. And then my curve is going back up. So I want to see what this peak is right here. So that's going to be a maximum. It's not my absolute maximum, but it is a maximum. So I'm going to select option 4 and do left bound, right bound, guess. I'm going to be to the left of where that occurs. Hit enter. To the right of where that occurs. Hit enter and guess. And I can see that I have a maximum value at 0.7, and I'm rounding to the nearest tenth and negative 2.7. So I'm going to graph that. That's going to be about right here. And now I am going to sketch my curve. It's down, back up, and then drops. So let's talk domain. Oh, and I did not label this one here as a local max. My domain, well, this graph goes forever to the left and forever to the right, so all real numbers. And my range, well, same thing, forever down, forever up. So I'm going to graph this quartic function. I already have it in my graphing calculator. And I'm going to begin by finding my zeros. So I'm going to hit second trace. I'm going to have to do this process, it looks like 3 times. So I need to move it to the left of where it crosses the x-axis. So I'm going to be slightly above, enter, move it to the right till it drops below, enter, and guess. And my first 0, or x-intercept, would be x equals negative 1 point, round to the nearest tenth, negative 1.9, so that's going to be right here, plot it. I'm going to repeat the process, second trace, and find the 0 in the middle. Now it looks like it's hitting at 0, but I'm thinking it might be shifted just a little bit to the right. So I'm going to hit second, do left bound, right bound, guess. And it does. It hits at 0, 0. So x is 0. And since it's bouncing off, I know it's there twice as multiplicity 2. And then I have one more, so second trace, option 2, move it close to where it crosses the x-axis. Need to be a little bit below. Enter, move it to the right so it's above. Enter again and guess. And there it is at 1.5. So I have 4 zeros, 1.5 is about here. And I am going to sketch, but I'm also going to need to label my peaks and valleys. So right here, this graph goes forever up, so that's not going to have an absolute maximum. This, however, is a minimum, and it's the absolute lowest it goes. So I have an absolute minimum value as an extrema. So I'm going to find that, and that's a min. So second trace, option 3 for min. And takes a little bit, but I got to get it to the left. Enter, to the right, enter, and guess. So my minimum occurs at the ordered pair, negative 1.3, comma, negative 3.5. And that's an approximation. So I'm going to graph that now. The absolute lowest it goes. Right here, I have a peak. What is that peak? I already have that listed. So that would be a local maximum. It would be like the top of a roller coaster. That occurs at 0, 0. And then I have another valley right here. So this one would be a local minimum because it's not the absolute lowest the function goes. That local minimum will be second trace. Let's see, I'm going to have to do the minimum process again. So moving it close, a little bit to the right, enter, enter, and there it is. 1.1, comma, negative 1 point, nearest tenth, it would be negative 1.1 when I round. So that is about here. All right, so now I'm going to make my sketch. Goes through, here's the absolute lowest, bounces off, goes through this, and back up. Final two things I need would be my domain and my range. So my domain is all real numbers because it goes forever left and forever down. And my range is different. Lowest it goes is right here, and then it goes forever up. So I'm going to need to write this as an inequality. Y is greater than or equal to this Y value. What was that Y value? Well, it was on my absolute minimum. Y is greater than or equal to negative 3.5. You definitely need to practice doing this on your graphing calculator. So please make sure that you're trying the steps with me or using your graphing calculator app if you don't have an actual calculator at home.